presence. Light energy. Programmed by John Ferguson Aditi. Learning objectives. After learning this unit, you should be able to 1. Demonstrate that light travels in a straight line. 2. Describe the operation of the pinhole camera. 3. Describe the formation of shadows. 4. Demonstrate the formation of eclipse. 5. Demonstrate the reflection and refraction of light. Light.
What is light?
Light is a form of energy that travels in a straight line, to enable us see objects. There are two main sources of light. 1. Natural source of light, sun, firefly, and glowworms. 2. Artificial source of light, flashlights, hurricane lamps, and electric lamps. Luminous bodies and non-luminous bodies.
What are luminous bodies?
Luminous bodies are natural or artificial bodies that give off light. Examples of luminous bodies are the sun, the stars in the solar system, firefly, glowworms and deep-sea fish.
What are non-luminous bodies?
Non-luminous bodies are bodies that do not give off light, or do not produce their own light. Examples are the moon, mirror, wood, and human beings. Note: the moon does not give off light, but reflects the light that falls on it from the sun. Incandescent bodies and fluorescent bodies.
What are incandescent bodies?
Incandescent bodies are luminous bodies that produce light when hot. Examples of incandescent bodies are the sun, lighted candle and tungsten filament lamp.
What are fluorescent bodies?
Fluorescent bodies are luminous bodies that give off light without being hot. Examples are firefly, deep-sea fish, fluorescent tube and glowworm. Transparent, translucent and opaque materials. Materials can be classified as transparent, translucent or opaque.
What is a transparent material?
A transparent material is a material that allows a large amount of light to pass through it, and we can see clearly through it. Examples are plain glass and clean water.
What are translucent materials?
Translucent materials are materials that allow some light to pass through them but we cannot see clearly through them. Examples are frosted glass, paper smeared with oil, or kerosene.
What is an opaque material?
An opaque material is a material that does not allow light to pass through it. Examples are wood, aluminium, metal sheet and human beings. Properties of light.
What are the properties of light?
1. It travels in straight lines. 2. It travels with a speed of 3 by 10, raised to the power 8 meters per second, that is 300 million meters per second, in air. There is no known substance that travels faster than light. 3. It can be reflected, that is they bounce back, on striking a smooth or polished surface. 4. it can be refracted. That is, light changes direction when it travels from one medium to another. 5. It can be diffracted. That is, light bends round corners or openings. Rectilinear propagation of light.
What is meant by the term rectilinear propagation of light?
Rectilinear propagation of light means that light travels in a straight line. Activity. To show that light travels on a straight line. Materials needed. 3 cardboards with holes at the center and a source of light. For example, a lamp. Here, the holes are aligned, or in a straight line. Here, the holes are not aligned, or are not in a straight line. Procedure. 1. Arrange the 3 cardboards A, B, and C, with a hole in their centers in a straight line, by passing a string through the holes, as in diagram A, above. 2. Remove the string. 3. Place the source of light, for example, an electric lamp, behind the first cardboard. 4. Observe what happens. 5. Displace the cardboard B slightly, so that the cardboards are no longer in a straight line, as in diagram B. 6. Observe what happens. Discussion. The light can be seen through the 3rd cardboard when the cardboards were in line. However, on shifting one of the cardboards slightly, the light is cut off from reaching the observer, behind the 3rd cardboard. This shows that light travels in a straight line. Ray and beam of light.
What is a ray of light?
A ray of light, light ray, is the direction or path taken by light. It is represented by a straight line with an arrow on it. This is a sample ray of light.
What is a beam of light?
A beam of light is a stream of light energy. It can also be defined as a collection of light rays traveling in a specific direction. A beam of light may be parallel, convergent or divergent. One. A parallel beam of light is a collection of parallel light rays. This illustrates a parallel beam. 2. A convergent beams of light is a collection of light rays which all appear to pass through a common point, or appear to incident at a common point. These are sample convergent beams. A divergent beam of light is a collection of light rays, which all appear to come from a common point or common source. This is a sample divergent beams of light. The pinhole camera. The pinhole camera consists of a box painted black on the inside, with a small hole at one end, and a screen of tracing paper or frosted glass at the opposite end. It works on the principle that light travels in a straight line. How the pinhole camera works. The diagram below shows a pinhole camera and how it forms an image. Study this pinhole camera very well. Light rays from various parts of the object placed in front of the pinhole camera travel in straight lines through the pinhole to form several tiny patches on the screen. These patches combine to form a real and inverted image of the same color as the object. Characteristics of the image formed in a pinhole camera. 1. It is diminished, smaller in size than the object. 2. It is inverted or turned upside down. 3. It is real, that is, it can be formed on a screen. Note the following about the image formed in a pinhole camera. The size of the image depends on the object distance, and the image distance from the pinhole, as well as the size of the object. 1. The image size and object size are equal, if the image distance and object are equal. 2. The image is bigger than the object, if the image distance is greater than the object distance. 3. The image is smaller than the object, if the image distance is smaller than the object distance. The size of the pinhole determines how sharp and bright the image is. 1. The image is enlarged and brighter when the object is brought closer to the pinhole. 2. The image is blurred but brighter when the pinhole is enlarged. 3. The image is sharper but less bright when the pinhole is smaller. Look at the pinhole camera below. The image is smaller than the object, because the object distance from the pinhole is greater than the image distance. Project. Construct a pinhole camera, and use the camera to take the picture of an object arid. Compare with the picture of the object taken with a modern camera. Materials needed. A matchbox, a new roll of film. An empty roll of 35mm film, an empty drinks can, black PVC electrician's tape, the plastic from a spiral binder, a fine sewing needle or pin, scissors, a sharp craft knife and a black marker pen. One. Remove the inner part of the matchbox, the match tray, and mark out a 24mm square exactly in the center of the match tray. 2. Carefully cut out the frame shape with a sharp knife, keeping the edges as neat as possible. 3. Color in the inside of the tray with a black felt-tipped pen. 4. Mark out the 6mm square exactly, at the center of the front of the matchbox sleeve, and cut the square out keeping the edges as neat as possible. Five. Cut out a 15mm square piece of aluminium from the drinks can, and make a hole with the pin, at the center of the aluminium. 6. Color the back of the pinhole black. 7. Place the aluminium onto the box so that the center of the square hole is at the top of the box. 8. Tape the aluminium onto the box, securing all 4 sides. 9. Cut one of the loops of the spiral ring binder. 10. Take the new film canister, and place the pointer at the end of the plastic, so that it just enters one of the sprocket holes of the film. 11. Tape the plastic to the film canister securely. 12. Trim the leader off the film, cutting the edge as squarely as possible. 13. Pull out a little more film and thread the film through the matchbox. Make sure the emulsion side, non-shiny side, is facing the pin hide. 14. Pass the film into an empty canister.